so we have to finish. I think we didn't quite do this one either. Is that true? I kind of got us a little bit started on this. So there was a question on the quiz where I did not have a 2 there. That one's much easier. This one's nowhere near as easy because I really want to make sure you guys understand why this one's different. What is the, physically, what's an inverse tangent? It's an angle. So if I had sine of inverse tangent, I could draw the triangle, I can get the sides, I could answer the question. But is this question asking about inverse tangent 3/4? Is it talking about that angle? No, it's talking about twice that angle. So if I draw the triangle for that, that has nothing to do directly with this question because it wants to know twice the angle. I'm like, God damn you, question. But, so there's a couple things I could do first. And it looks like I started going down this route, which is fine. Everybody see how it's that sine of twice some angle? Yes? Do we have an identity for that? What's the identity for that? 2 sine theta cosine theta. Wow, you're nervous today, little dude. It's gonna be okay. What are both of these talking about? What angle are they talking about? They're talking about this angle here. So they totally relate to the triangle I can make. Can you guys take a minute, make the triangle that this is referencing? Don't say anything. Just what triangle is that angle referencing? I'm like, you already drew it, Jeff. No, but be more specific now. Every inverse trig can be represented with a right triangle. You just have to put the numbers in the right place. But this one is saying the tangent of the angle that lives in this right triangle is 3/4. So where does that stuff go? Where's 3 go? Go ahead and tell me. On the y side, because tangent is y over x. So this will be 3, this will be 4. And then, of course, by now, hopefully everybody knows 3, 4, 5. That kicks ass. Look at Jeff being nice. So now I can answer this question because it's the same as this question. And this question, I've got a triangle for this. I don't know shit about twice the angle. I don't know shit about that. If I double this angle, what happens to the sides? I have no freaking clue. Are you kidding me? But both of these are talking about this dude. So what's the sine of the angle? What's the sine of theta? What's the sine of theta?
3/5.
3/5. What's the cosine of theta? 4/5. So if I multiply that business out, what do I get? 24 25ths. Okay. Okay. You guys kind of with me? So I desperately want you to see, if I ask you a question like cosine of the inverse cotangent of 7/6, that needs to be easy as shit. It just needs to. Because what's the easiest kind of questions I could ask you about trig functions? I give you a triangle with all the sides, and I just say, what's the sine of it? And you just have to get the y side over that hypotenuse, right? Right? That's the easiest kind of question I could ask you. This is one step from that. I haven't drawn the triangle, but I told you what 2 of the sides are. What 2 sides have I told you about? Yeah, what's the x side? It's cotangent, remember? So it's 7. Tangent's y over x, cotangent's x over y. And then this I would get by 49 plus 36, which is 85. Is that right? And I don't think that goes anywhere good. Does it, Jeff? I don't know. 12, 14, 17? No.
17.
You guys, is everybody cool with what just happened? If I have an inverse trig, that is referencing this right triangle because it's saying the cotangent of the angle is 7/6. So that's the right triangle I can immediately draw. And then they can ask me any damn question they want to about it. Easy. So what's the cosine?
7/85.
Which is also known as
7/85/85.
Yeah, rationalize that. Okay. Okay, so let those be unbelievably easy. Let them. They kick so much ass. They're actually, that problem is actually easier than the one I gave you earlier about like inverse sine of √3/2. To be honest, because if it's negative inside, you got to be careful. Blah blah. You got to remember. Yeah. Okay. So let's look at these down here. I want to know all the solutions. So can anyone tell me what quadrants fundamentally we must live in for this problem?
1 and 2.
Yeah, it would be like 1 and 2. Now here's one little trick. The output is 1. How many places between 0 and 2 pi is sine exactly 1? 1 place. So this is so it should be 1 and 2. That's where sine's positive, and unless it's the boundary between them, and then it's just that one place. So of course, what's the base answer? What's the fundamental solution? I have to find all the solutions, so I'm not going to be done. But what's the base solution? Pi/2. That's where sine is 1. Yeah. Sine likes y. It's going to be biggest on the y-axis. So the fundamental base, whatever the word you want to use, is this. And then what do I do to get all the other answers?
Plus or minus 2 pi k.
2 pi k? Remember the old commercial Parquet?
Butter.
Yeah, butter. Is that right? And of course, they're going to do 2 pi k because then I'll end up on the y-axis again. And it doesn't matter if I go forward or backward. So I can't remember the book put plus or minus, but I always put plus or minus just so it's in your face. Then you go forward, you can go backward. Part B. What's the first thing I should do on part B? Square root. And when you take a square root, some of us are forgetting this. You must put plus or minus. So we get cosine x equals plus or minus. Real quick. Square root of 1 is 1 over square root of 2. 1 over square root of 2 would be square root of 2 over 2. Just rationalizing that. Does that look like a familiar value?
Yes.
Hell yeah. It could be positive or negative, which is what that weird looking thing is. That's a plus. So what quadrant do we live in? All of them. I love it. So where is cosine output rad 2 over 2 of any stripe? Yeah, pi/4 reference angle, right? Now, real quick. Here's where you want to give yourself a visual. This one, I need you to understand, this one's a little bit special. Because the answer is 1. There's only one place that's 1. It's not a lot going on here. This guy is all over the damn place. So if I give myself a visual, one answer is here, the other answer is here, another answer is here, and another answer is here. So if you wanted to list out all the answers from 0 to 2 pi, it would be pi/4.
Plus or minus.
No. Pi/4. What's this one? 3 pi/4. 5 pi/4. 7 pi/4. I like, right? I don't need to do that. I don't need to list them all out. And I want you to be with me. Why did we do this again? Because the answer is 90 degrees. And then I go forward or backward. And I'll end up in the same place, yes? I could do each one of these 4 and go forward a full rotation, backward a full rotation. But isn't there a more efficient way to pick up all the freaking answers? Every single answer is how far away from the one before it? pi/2, right? So I don't have to list all 4 plus or minus 2 pi k. That's insanity. I just have to say, okay, if I start at pi/4, how much do I add to get to the next guy? And how much do I add to get to the next guy after that? Another pi. So I'm going to add or subtract a multiple of pi over 2. I need you to see that. This is why you want to give yourself a visual so you can see when you're allowed to do that. It's when they're equally spaced. So all I have to do is start here, and if I start here, I can get every single answer if I take smaller steps. Don't go all the way around the circle. Go pi over 2, pi over 2, pi over 2, pi over 2, and you'll get all the freaking answers. So this would be plus or minus what?
Pi over 2k.
Pi over 2k, I like it. So things get weird when you have like a squared trig. You should expect weirdness. But they could get weird in other times too. You just need to give yourself a picture. Let me see. I should have given you this problem. So I'll give you this problem right now. What if I would have said, what was this? Yeah. Sine squared equals what? 3/4. What's the first thing you do? Square root. So got to put plus or minus. Square root of 3, I don't know. Square root of 4 is 2. Sweet. Does that look like a familiar value? What reference angle are we talking about now?
Pi over 3.
Pi over 3, 60 degrees. That's where sine's bigger because it's closer to the y-axis. Okay. Dadgummit. Let's see if I can get this on here. Okay. So this will be pi over 3. Where else does it work?
One,
2 pi over 3.
2 pi over 3.
Where else does it work? 4 pi over 3. Where else does it work? 5 pi over 3. How far apart are these two? Pi over 3 apart. How far apart are these two? Damn it! I need you to see. If I told somebody to start here and take a step of pi over 3, they would get to the next answer, yes? What if I told them to take another step of pi over 3? Is that an answer? Holy shit! So I can't have one answer and get all of the things by doing the same step size. I have to put plus or minus something times k. I want to do so many steps. I can't get... But if I start here, can I get to there? That's a 3, by the way. Good Lord, Jeff. I still can't see, okay? All right, no, I just suck. All right. How far apart are these two? Pi. And how far apart are these two from each other? Pi. Oh! So I can start at pi over 3 and go forward and backward by multiple of pi. And I can start at 2 pi over 3 and go forward and back by multiple of pi. So that's a whole little end of the problem analysis you have to do. And if you don't draw a picture, I don't quite understand you. You have to figure out, how do I capture everybody? Now, if you put pi over 3 plus or minus 2 pi k, 2 pi over 3 plus or minus 2 pi k, 4 pi over 3 plus or minus 2 pi k, 5 pi over 3 plus or minus 2 pi k, you're technically not wrong. You're just doing it incredibly inefficiently. Depending on how I feel, I might take a point off. We'll see. You guys, I'm not going to go so far as one of my teachers who gave us elegance points. So it'd be like minus, I always had a negative elegance score. Because I just got the answer as quick as I could. It's like, it's not very elegant. Shut up. Sorry. Dr. Hoy up there. I'm sorry. You did fine. Okay, coming back here. What's one little thing in this problem that's going to throw us off?
3x.
Yeah, the angle is triple something. The first step, you don't give a shit about that. 3x is an angle. I'm going to solve for it first. The tangent of what is negative rad 3? So first off, what quadrants are we living in? When is tangent negative? Give it a nice clean piece of paper.
2 and 4.
Yeah, in quadrant 2 and quadrant 4. So I know I'm living in quadrant 2 and 4. I have no idea how you guys have tangent memorized, or if you do. I don't know. The way I remember it is... Can somebody tell me what are the values I could get out for tangent? One of them is square root of 3. Does anyone know another value I could get out for tangent? 1. Rad 3 over 3. 0 undefined. Right? I remember. What's on top of tangent? Sine. Tangent goes like sine. Tangent is bigger when sine is bigger. Square root of 3. Is that the bigger option for it? Yeah. It's bigger than 1. And it's bigger than rad 3 over 3, correct? I don't care about the 0 and undefined bullshit. That's the extremes. I'm talking about in between those two. What's the biggest possible output? Rad 3. I want you guys with me. I need you guys with me. Because I don't have tangent memorized. Screw that shit. I just remember tangent is like sine. So when is it bigger? When sine's bigger. That's bigger. That's bigger than 1. So it's bigger than 45 degrees, right? And it's bigger than rad 3 over 3. So what angle must that be at?
Pi over 3.
Pi over 3, 60 degrees. I must be at pi over 3. I must be where sine would be happier. Because tangent's pretty happy, and tangent goes like sine. I don't know if that helps you guys out. Or you just straight up memorize tangent. I don't know. If you guys have done none of that shit, you better do that shit. Okay. Memorize tangent somehow. So I know I'm talking about pi over 3 kind of angles, correct? So in quadrant 2, what would that translate to? 2 pi over 3. And in quadrant 4, what would that translate to? 5 pi over 3. How far apart are those from each other? Pi. So can I pick them up? So what can I do? I can start. So 3x, that angle, is equal to 2 pi over 3 plus or minus what? Pi k. I can go forward pi and keep going forward pi, or I can go backward pi and keep going backward pi. And I'll pick up another answer. I'll never pick up something that's not an answer, and I won't miss any answers. And then what's one more step to get to finish this? Finish it.
Get rid of the 3.
Divide by 3, divide by 3, divide by 3. So I get x is 2 pi over 9 plus or minus pi k over 3. I really hope you guys get to a point where that's just that easy. Divide by 3, divide by 3 again. Of course you're divided by 9. Of course you're divided by 9. Or 2 pi over 3 divided by 3 is 2 pi over 3 times 1/3 is 2 pi over 9. You can multiply by the reciprocal.
Why was I thinking I wanted to take the inverse tangent of each side?
Oh, nothing wrong with that. But this is a number we know. So let me give you, I've sort of given you very nice looking equations, which for the most part we're going to work with because I care more about what you can remember. But if I had a problem like this, you can do it, Jeff. 1.11. Is that a value we're supposed to know? No. Okay, so what quadrants are we living in, though? Tangent's positive. 1 and 3. Yeah. So whatever this angle is. Now, Denny, how do I figure out what the angle is? Do what you want to do. Do what you want to do.
Take the inverse tangent.
Take the inverse tangent. How do I know when I have to do that when the value I give here is not one we know? It's not rad 3 over 3. It's not rad 3. It's not 1. Then I know I have to use, that's the only way. So x is the inverse tangent of 1.11. Real quick, what's the inverse tangent of 1? When is tangent 1?
45?
Pi over 4.
Or 4?
Yes? Tangent is 1 at pi over 4. Is everybody with me? This is a little bit bigger than 1. So it's a little bit bigger than pi over 4. Pi over 4 is roughly 0.75. So if does somebody have their calculator? I'm going to guess it's 0.82. Something else. Probably bigger than that. It's fine. 0.8. I don't know. I'm going to stick with that. Sorry, it's my one skill I got to show off. So 0.838, roughly? Okay. Now there's not a ton of these, but I do want to talk about this. I'm glad you brought this up. That's not a thing I know. I've got to use inverse tangent just to get the freaking idea. It's 0.838 radians. That's what this is. So how do I pick up the next answer? Pi, okay, yeah. They're automatically going to have to be pi apart, because to make this triangle the same as this triangle, they have to have the same angles here. Same reference angle, right? So they're going to be pi apart from each other. So that's a quick example. I think there's like one or two in the homework like this. Take the inverse tangent, you get it. It's in the first quadrant. You add plus or minus pi k. It's the same idea. It's just we don't get it from our heads. We don't get it from our memory. We get it from the freaking calculator, because we don't know if the shit angle makes tangent 1.11. Okay. Maybe? Technically, that's what we're doing here. Let me see. Where did I do it? Here we go. Let me see. Can somebody do the inverse tangent of negative rad 3? If you have a calculator. Inverse tangent of negative rad 3. Make sure you're in radians. So the inverse tangent of negative rad 3. I get this. And that would be this. So it should be pi over 3. What is pi divided by 3? It should be negative pi over 3. So what is pi divided by 3? It's that. But why didn't I use the calculator for this? Because that's gross. And pi over 3 is nice. And I want you to understand. It's the same thing. It's the same thing. We're just using what we've memorized for this, because it's a value we know. If I give you one like that, we just have to use the inverse tangent, which does the same thing we did. It's just not a pretty answer, right? It's just thinking backwards. What angle makes tangent 1.11? I need the calculator because I didn't memorize that. Damn, Jeff has me memorizing enough. I'm not going to do that too. Okay. Maybe. All right, so focus of today. And then tomorrow is going to be sections 10.1 and 10.2. Oh shit, what have I done? Okay, there's one thing.
And tomorrow you'll give out the chapter review?
Yeah, tomorrow I'm going to give out the practice test.
Okay.
Yeah. God damn it. What did I do with it? Well, there's one thing. Earlier I proved the thing. Is that for now? No. Oh, I can do the other one. Yeah, screw it. Sorry. I just had a little thing. I just wanted to make sure I could prove these, so I did them real quick, and now I don't know what to do with them, but I can do it again. So far, and in fact, it only makes sense. What are all trig functions based on? All trig functions are based on what? What kind of triangle? Very specifically. They are based on right triangles, correct? I sort of mentioned this before, and we're there now. How can trig help us if the triangle is not a right triangle? Can trig help us? And the immediate surface level answer would be, well, no, of course not, because they're built off of right triangles. But, for example, it doesn't matter, Jeff. Let it go. I had set it up a certain way, but now I'm just going to set it up whatever happens. Whatever happens, happens. I'll make that C, I'll make that A, I'll make that B. B, C, A. So this is not a right triangle. Does everybody agree? Even though my drawings normally suck pretty bad, I think you all agree with me that that's the only angle that might have been right, and it's not right. Yes? It's just not right in the head, kids. Okay. So then you might think, okay, trig does nothing for me. But of course it does. Trig directly relates to right triangles. Pretending like this is a straight line, yes? If I drop that down, didn't I just create two right triangles? You guys kind of with me? Okay. Does that side Y live in more than one right triangle? Yes. Can somebody, what would sine of C be? Would sine of C involve A at all? Could it? Could cosine of C involve A at all? Hell no. Is the sine A in a right triangle? No, isn't this is not A, is it? This whole freaking thing is A. So no trig function I would set up for the right triangles I've created would involve A, because it's not in a right triangle. It will eventually get to a point where I can write an expression that involves A, but not just a straight up sine, cosine, tangent. None of them can touch that. But what is sine of C? Yeah, because Y is in the right triangle and B is in the right triangle, so Y over B. What is sine of B? Looking at that right triangle. Y over C. What's the same in both of these? Y. Solve this for Y. What do you get?
B sine C.
Solve this for Y. What do you get? Should really, capital C sucks, because it's basically lowercase c, but oh well. And what must be true about B sine C and C sine B? They have to be equal to each other, because they both equal Y, right? So B sine C must equal C sine B. It sounds like a tongue twister. Shishal. And you're all like, this is so exciting, Jeff. I'm so happy we're doing this. I'm going to divide by little c, and I'm going to divide by little b. Now, without doing it all again, that's neat. Does anyone agree that that's kind of neat? In the context of this is math. For math, that's kind of neat. That's nice. Couldn't I just turn the triangle around and do the same thing I did? I could just do it again, and this time it would involve, what have I left out? A shit. If I do this, if I drop it down like this, I can just do the same thing for A, so this also equals. That's awesome. Does it have to be a right triangle for this to be true?
No.
Hell no. Of course not. No. It doesn't have to be right. Is this a right triangle? Is this whole thing a right triangle? Hell no. Doesn't it have side A, side B, side C in it? Doesn't it have angle A, angle B, angle C in it? Okay. So this one looks like nothing we've seen before. Y'all agree? But now I can do stuff like this. Let me do one quick example. I'll make something up, and it will suck. It will suck. Let's see. Sorry. 30. Let's say 32 degrees. And then we'll say 48 degrees. And I'll tell you that this is, you can do it, Jeff. 3. So what the problems are going to look like in 10.1 and 10.2 is it's going to say solve the triangle. And that sounds so weird. You're like, what do you mean solve the triangle? All I mean is any sides or angles you weren't given, you must figure out. So what can you immediately figure out without much trouble? Anybody? Yeah, the other angle. Now this is not drawn to scale. My poor little triangle. but we'll be okay.
100,
Yeah, what do I have so far?
80.
80. So then this must be 100, like Denny said. It's obviously not 100, but oh well. I don't know if I'm going to allow that to stand. That's so bad. Okay, sorry. So 32. 48. All right, that'll be a little bit better. And then this will be 100. Okay. You don't have to change shit. You're fine. You're fine. I just want to do this for myself. And I also want to make it tinier, just so it's harder for you to see what's going on. So it's up to you. What do you want to call? What do you want to call this side? This should be little b, by the way. That's my bad. Wait, what did I say? That was 3, right? Okay. Sorry. I'll catch up with my own writing someday. You see why I thought it was a B, because I crossed it out like that. So what side do you want? What do you want to call it? I need to call a side A. I need to call a side B. I need to call a side C. In this case, it doesn't matter what's what, because there's no right angle. So what do you want to call this side? C. I like it, because we're normally drawn to the biggest side being C. I like it. Why do I know that's going to be the biggest side? Because it's got the biggest mouth. Yes? So it's got the biggest stick that could fit in it. What do you want to call this side? A. And so we'll call this side B. So this is angle B. Do you see how angle B is across from side B? That's crazy. Angle A. And this will be angle C. Okay. So now, tell me this. Riddle me this. What tells me I will not always be able to use this? And by the way, Jeff, does this thing have a name?
Yes.
Yes.
Law of science.
You ready for this amazing name? Law of science.
Shocker.
I know. We're really good at naming things. The law of science. I know the law of science will work if I can make a complete ratio. If I cannot make a complete ratio, I'm going to have too many unknowns. Let me say this again. When can I use law of sines? When I'm given a triangle with enough information that I can make a complete ratio. What do I mean by complete ratio? Do I know angle C and side C, or any of these? What complete ratio can I make? What angle does it relate to?
Angle B.
Angle B. So we're going to do sine of angle B divided by 3. And now it's up to you. You can pick one or the other. We can solve for each of them. Who do you want to solve for first? A or C?
C.
C. Okay, so then sine C divided by side C. I love it. Solve that. I'll wait. Solve it. I'll just stand here and stare at you. You need to borrow a calculator. You can do it. By the way, this is trying to be degrees. So very quickly, before you do anything, make sure you're in degrees. Oh man, I'm so tight. Shite. Here, while you guys are doing that, this is a copy of the updated homework sheet. All right, so let's see. So it'll be 3 times. Oops, I'm not in degrees here, am I? Nope. 3 times sine of 100 divided by sine of 32. So I get 5.57. Blah blah blah. 5.58. And then how do we get A? How do we get A? Instead of putting this here, I could just put the stuff about A, yeah? So it'll be sine 32 over 3 equals sine of 48 over A. So it'll be 3 times sine of 48 divided by sine of 32. What do you guys get? Yeah. We'll round to 100's place. Why not? Real quick, who's got the biggest mouth?
C.
C. And which is the biggest side?
C.
C. So that's a quick check you can make at the end. The smallest side has the smallest mouth. The biggest side has the biggest mouth. At least at that level, it makes physical sense. That's almost too good to believe. Now, last thing I want to say real quick, and then we'll head out. We're not going to get too deep into this. You don't even have to remember this necessarily, but does anyone remember shit like SAS? SSS. So the situation we just had, I gave us, let me see if I can recreate this real quick. No, Jeff. I gave us, what did I give us to begin with? Oh yeah, these two, and I gave us this one. So that would be angle, angle, side. Or side, angle, angle. I don't know which way your teacher said. Now, the really funky thing, the one kind of triangle situation that could lead to really weird outcomes is appropriately named. You guys remember SSA? Now that would be side, side angle, which I affectionately call ASS. That's a much better name for it because it's the one thing, and again, I know, I got a weird, not necessarily technical way to describe some of this stuff, but it makes it really easy to remember. If I give you one side, an angle, so an angle, a side, and then another side. I need you to understand. Let me see if I can make this. This is what I'm going to focus on here at the end. I'm going to draw this on the board and see if I can do this. Should have done this earlier, but too bad. Come here, you. Not you, sorry, Jenny. This thing. And it's like, what do you want me to do? Let me see if I can make this work. So if I give you an angle, I need you to understand, I didn't say shit about this side, did I? I have no idea how long that side is. I give you an angle, I give you a side, so we know that this angle is a certain size, and we know that this side is a certain size. Let me make sure this is going to work. Ooh, it's going to work beautifully. Ooh, it almost works the way it works the way it, not quite. It's a little bit longer. Okay. Oh, that's a little too long. Okay, we're going to get there, kids. Okay, that'll work maybe. Yeah, that'll work. Okay, that'll barely work. Okay. I need you to really understand this. So I'm giving you pieces to put a triangle together. However long this side is, it's got to be a certain angle away from this side. So I gave you this angle, I gave you this side, and I gave you this side. Do you see how this angle is not set? I didn't say what that angle had to be. Couldn't this sucker swing? So look, if I do this, does that make a triangle? With this side of this side here, right? Yeah. Can't I swing this in and make another really weird-ass freaking sliver of a triangle? Yes? So I can have another triangle freaking here, or I can have a triangle here. Interesting thing about this freaky triangle is it's isosceles. Of course it is, because it's the same length. Does that matter? No, I just want to point that out. So what does this mean, Jeff? This means that if I'm given an angle, side, side. So I don't know this, I don't know this, so stuff can swing. I could have two triangles at work. I could have one triangle that works. It only works like right there. If I made this taller, it would only work right there. Or it could have no triangles. So how would I make one that has no triangles that work? Well, I just make that way too freaking long. Look at him. Ah! Can he ever make a triangle? He's not long enough, poor little dude. So if they give me the wrong parts, there could be no triangle I can make. Poor little guy. Okay, sorry. I'll stop playing. To me, that's really neat. It sucks, because you're going to have to figure out two triangles sometimes. So one thing I'll focus on tomorrow is, what does that look like, right? So tomorrow I'll hand out this. I haven't proven the law of cosines. You know there must be a law of cosines, and there is. That's the one that's really cool because it's got Pythagorean identity in it. So we'll prove that tomorrow. I'll have this handout that will go over both, and then we'll do several examples. And then the next day will be review day. So tomorrow I'll have the practice test for you guys. Thank you. Maybe if you think about it, I'll post it on Canvas later today, so you have it a little bit longer. Okay, that's enough.
Professor Davis calls that the T-Rex.